Hi. My name is Tyler Huggins. I was invited here to talk about some of the work I've been doing in upgrading brewery byproducts into Mycoprotein. So I haven't really given many presentations without like a PowerPoint. So it's a little awkward. So please let's have this be interactive. Ask as many questions as you want. I'm here to just to talk and talk about our process and kind of the lessons learned. So I'm curious, how many of you are here because you're interested in sort of the upgrading of brewery byproduct, and how many are interested because of the mycoprotein part of it? How many of the brewery and mycoprotein? Okay, cool. Just good to know. Talk about one or more than the other. So my name's Tyler Huggins, like I said, CEO and co-founder of Emergy Labs. We're a food startup out of Chicago, and we are on a mission to make delicious, nutritious, affordable, and sustainable protein accessible to everybody. So in order to do that, we're leveraging a proprietary technology that we developed to grow mycoprotein. And our protein production efficiencies, we're getting around 20,000 times more protein per acre than conventional agriculture. We can do this using nearly 99% less water, energy, and greenhouse gas emissions compared to conventional agriculture. So this efficiency is something that's really important to me. As we saw, I'm sure plenty of these talks today, there's a lot of really cool excitement around alternative proteins, and there's no doubt that converting to more of a plant-based diet is better for people, the environment, and animals. There's no question about that. But the demand is so high when it comes to protein production. It's nearly unquantifiable, especially over the next few years, or until around for the next 20 years or so. We're going to nearly have to double our protein supply. And I just flew from Chicago. I'm looking out the window the whole time, and it's farm to farm to farm, from Chicago to San Francisco. And how are we going to double our protein production? Even if we switch to plant-based proteins, we still have to grow and cultivate the crops, right? And our current agricultural system isn't perfect. It still is very energy, water, nutrient intensive, still requires a lot of mechanics and machinery. So in my opinion, fermentation technology to produce protein has a lot of potential. Because one, it's a controlled controlled cultivation conditions, right? We can dictate how it grows. It's vertical, meaning that the footprint is very small, and it's decoupled from climatic conditions. So no matter what's going on, with changing with climate, we can still have a productive system in place. But the challenge is most fermentation technologies are not decoupled from agricultural processes. So we still have to rely on agriculture, plant-based production, in order to provide the nutrients for fermentation. So it's still efficient, but I think there could be a lot of room for improvement. And so that's where I've spent the last about 2 to 3 years using government grant money at Argonne National Laboratory and the University of Chicago, or University of Colorado at Boulder, to look for ways, sort of underutilized nutrients that we can use as cultivation media for mycoprotein production. And that's one of the advantages of using fungi produce mycoprotein, is that it's a much more versatile platform or organism to work with. It's the decomposers and the recyclers of nature. So it can handle a variety of different feedstock, be able to break it down and assimilate it into proteins. It's a really unique property over other platforms, if you will. So we looked into the industry, in fermentation in particular, your carbon source, or your sugar, equates to nearly 50% of your cost of goods, and is one of your highest inputs, your raw materials. But yet every day, millions of gallons or millions of tons of carbon just gets thrown away in so-called wastewaters. And in particular, there is thousands and thousands of gallons every day being put into the sewer of food-grade wastewaters. So these are byproducts from food and beverage processing that are full of carbon and full of nutrients that we could use, and that actually cost producers money to treat. So it's actually a burden for them. But for us, we looked into it as, wow, that could be a great feedstock for our process. So with this concept in mind, and please ask questions if you have any. With this concept in mind, we looked around at different industries that we think might be the most receptive to this. And breweries in particular is a great fit. I mean, I do love breweries, I'll be honest, and so I spent a lot of time there, and it seemed to be a good fit. But the industry itself is also very progressive, looking to be sustainable, looking to be closed loop if possible. It's just a challenge for them. Breweries and most food processors, that's what they do, is they brew beer, and that's the most important thing. But most of them will actually have to have a wastewater treatment plant on the back end of their brewery to treat this byproduct stream. So we spent a lot of time asking them a lot of questions of, would this be something that you're interested in? And for the most part, across the board, from microbreweries to the large breweries, the idea of taking this stuff off their hands, maybe even having them pay you to take it off, was a possibility. And so for the past 2 years, we've been working with breweries, identifying highly nutritious and food safe byproduct streams from the brewery process to feed into our fermentation process. Like I said, we work from small microbreweries all the way up to some of the biggest breweries in the country, and trying to tap into their process and see if this is a feasible method of mycoprotein production. And what we found is that it was a great way, highly nutritious byproduct stream, uncontaminated source. I mean, it's the same stuff that goes into beer we can use as nutrients for mycoprotein production. And in the end, we're able to nearly eliminate our raw feedstock costs, bringing the cost of protein production down to nearly 25 cents a pound. So if you think of chicken is around $2 a pound wholesale. So this is a significant advantage. But you still have protein content that's well above even a chicken breast or a beef, with even a higher nutrient profile. So the potential here is really astronomical if we can get it to work. So some of the lessons I learned, we probably won't pursue this for at least the next 3 years. We've identified actually using off-the-shelf carbon sources is the most viable way to get to market. And the reason why is mostly the status quo bias, right? It's sort of a chicken and egg problem. You go to these breweries, their main objective is to brew beer. They don't want anything to mess up that process. And the only way you can make the economics work is if you integrate these two processes together. And I think they'll be okay with that, but the problem is they've never seen it done before, right? So we need to build a standalone plant, show that we can produce this at scale, show that this process works and that there's a demand from consumers. With that in place, we have, again, some of the biggest breweries in the country who have agreed to work with us in this process to slowly but surely integrate these new systems into their process, and ultimately, hopefully create one of the most sustainable proteins, I believe, that would be on the market. And the other advantage of working with bigger companies that have a national distribution is that there's Budweiser and Miller Coors breweries, Heineken breweries all around the world. Africa, there's some very large ones. India, you name it, China, for example. And here are places where nutritional protein is even more demand than it is here. And we can get the price down to a point where it'd be economically viable for customers in those markets as well. So I think that's the long-term goal. But in the near term, again, we're trying to build out these pilot plants and be able to show and demonstrate what we can do using, say, off-the-shelf carbon sources, before then integrating in other sort of lower cost alternatives. Any questions on that?
What is the output?
What is the protein output?
What is the form?
Yeah, so with mycoprotein. So mycoprotein, and in particular our process, is essentially like the roots of a mushroom. Like the roots of a mushroom, so the mycelium base. It is very fibrous, thread-like structure. So that allows us to make stuff like meat alternatives with that texture, and actually and some of the same flavors as you would in in conventional animal-based meat. It's about 60% protein by weight, with a variety of different, high fiber and.
Choice of powder or solid. That is what.
Well, so during the cultivation process, it's very fluid, right? It's hard to explain until you see something like this in person. But during the cultivation, basically, similar to like brewing beer, but we grow fungi, right? Filamentous fungi, so these long strands and these fermentation processes. We can then pull it out and de-water it, and you get basically a highly fibrous end material that, again, we can blend into a variety of different meat alternative ingredients. Yeah, then we have a variety of different post-processing steps in order to get it to a finished good. Again, we can make things like meat alternatives that have, high moisture content, taste and texture like meat, and also dry it all the way down to like a functional flour, and then be able to blend it in with baked goods.
So you work with filamentous fungi. Is it Aspergillus, Trichoderma? What kind of?
We have our own proprietary strain, and at this moment, that's kind of a secret sauce. So the biggest barrier to scaling up is getting the capital for getting money for CapEx costs. It's very hard for investors who are used to investing in software to put a couple $1 million into stainless steel tanks. The beauty of it is, and I think some that are very interested, is the upside is just huge. Again, it's not a demand side problem, it's a supply side problem. So over the last 2 years, we've developed the metrics in order to what we believe efficiently scale. Now it's an engineering issue of we just need to build the plants.
Just wondering, because your companies have some geolocation restriction based on where the brewery is, and then you have to build next to it, right?
Yep. Yeah.
They can be very spread out across
Yeah.
the nation.
Yeah, so we see the only way to viably do this as a large scale company is to partner with large domestics. And the nice thing about large domestics like Budweiser and Miller Coors is that they are spread across the country, near large metropolitan areas. And so we look at it as ideal locations in some applications. Yeah.
Would the product similar to like commercial product like for corn?
Yeah.
Similar type of product?
Yeah.
Different.
So the question is if we're similar to corn. Corn is definitely the incumbent when it comes to mycoprotein. They've been in the industry for close to, I think, like 50 years now. All their patents are publicly available, and it's interesting because if you read their interviews, they're like, you can try. But it's very difficult in order to do what we do, and that's what we have found. This process is very sophisticated. I wouldn't recommend it for an amateur. Their particular strain too, you have to be able to. So this whole idea of using byproducts as a nutrient source is challenging because you have to use a strain that can handle swings in nutrients and that doesn't produce mycotoxins. So corn's particular strain does produce mycotoxins, and so it can't be a treatment process. So we can't consume all the available carbohydrates and sugars and get it low enough, because then it becomes unhappy and can actually be potentially dangerous. And so we've developed a lot of what our IP is surrounded around is how do you actually make this a treatment process? How do you actually have clean water coming out of the back end while recovering and producing a high value material that's safe for human consumption? So that's a big difference, I think, that we've been able to work on. So fermentation process, very similar to beer brewing. Large stainless steel tanks, but we're not actually making the fruiting body of the mushroom. So the fruiting body, like you see in the forest, is actually only about maybe 10% of the actual fungi. The rest of it is in the soil in these long strands. And so that's what we're growing. We're growing that long fibrous structure, in a submerged fermentation process.
You said that mushrooms make mycotoxins because they're unhappy, they're like not doing well?
Yeah, so this idea around mycotoxins, so some strains can't produce mycotoxins. Our particular strain does not produce mycotoxins no matter how you grow it. And so I think as we move forward in this industry, we need to be very particular of what strains we use in order to make sure we have safe products for human consumption.
Does that mean your end product would have the same allergen implications as your?
Yeah, exactly. Yep. Any other questions? Yeah.
Do you genetically modify the strains?
No. Yeah, so we've strained, we've tested, over a couple thousand different strains, naturally occurring strains in the environment, looking for a variety of different things. High protein content is really important. Growing really fast. So based on our calculations, we have one of the second fastest growing organism on the planet. Like, essentially, we can turn around batches within 12 hours. And no matter how big the fermentation, our doubling time is only around an hour and a half, which is extremely fast. Taste is a big one too. We want to make sure it's completely white, which is also very nice. You can then blend it into a variety of different things without having those colorings, and then just ease of cultivation. So based on those parameters, we strained tons of different variations and found the one we believe is the best fit.
Do you have the specific amino acid protein profile?
Yeah. So we have a complete protein as well, which is another nice feature of most fungi is their complete proteins. Any other questions?
Well, because no one else asked.
Yeah.
Can you just explain, it's weird how you're saying that if a mushroom is not in a good situation, that it will create toxins.
Yeah.
Why does that happen?
This can happen in a variety of different organisms. With these particular industrial strains, I think it's a signal. It's a natural signal to the environment that things aren't going right. Whether it's under stress or maybe being attacked by other. You got to imagine mycelium is spread across, the forest floor. It only has one cell wall thick, but yet there is billions of bacteria present in the soil competing against it and trying to consume it as well. So fungi and bacteria have been evolving together for, billions of years and have developed mechanisms to be able to coexist together. And so a lot of that is, I think, something that we've been trying to do is how do you take these natural systems from the environment and then be able to control them instead of having them sort of be, uncontrollable or unpredictable. We've developed methods to actually be able to turn it into sort of a true manufacturing process, to be able to dictate what the end product is going to be based on how you grow it. And there's so much versatility in that process where you can produce a variety of different desired outcomes, like highly nutritious, good texture, great taste. All that's during the cultivation process, and that's the advantage of having bioreactors in a fermentation system.
So you mentioned you also work with microbreweries. Have you done an analysis? Because I would assume if you're going to collect the outputs from microbreweries, you will need to consolidate to run the plant.
Yeah.
Have you done an analysis of what kind of radius you can manage economically when you have transportation costs involved?
Yeah, that's where, so his question was, can we work with maybe a large group of microbreweries, like in Chicago? I think there's 200 and just in the Chicago region. I don't think that's a practical option. I think what we're going to want to do is build a plant on the back end of a domestic brewery. That is where, these domestic breweries, I don't know if you've ever been to one, but they produce millions of barrels of beer a year, and they're producing thousands of gallons of wastewater per day. So that's where you want to tap onto. To give you an example, based on our calculations, with one domestic brewery We could provide, be able to supply protein, so having like a meat alternative 3 days a week for nearly 1 million people off of one like Budweiser plant. So there's a lot of potential output from just one of these facilities. And then you could go into dairy processing and potato chip processing, wineries. I mean, there's so much out there as far as available nutrients to convert. It's just about designing systems to integrate into it properly, and then also the public perception issues of how do we brand that? How do we make people excited about that it's something that's good for them and good for the environment?
How quickly do you know how quickly they grow? Like specifically, how long might it take for the mycelium to grow 1 millimeter and then 1 meter?
The hyphal growth length, tip growth, I don't know off the top of my head.
In general?
Yeah, off the top of my head, I don't have those numbers. Again, we're looking at more biomass production, more than hyphal growth. But as I mentioned, we have a doubling time of nearly an hour and a half. Yeah. There's a ton of control. It's just amazing. Again, that's where I was trying to allude with the process parameters, and how you grow it can dictate all sorts of different features, from hardness to softness to how long the fibers are, whether it's like a ground beef versus like a long range, like a chicken breast. All that stuff is during the cultivation side. And then when you post-process it as well, there's so many different other ways you can do with water content and mechanical processing that you can then manipulate the final texture. Yep.
Does the speed it grows different? Is it dependent on what you want the final product to be? So that's why it's starting.
It's a lot of this is strain dependent.
Okay.
And that's something that's interesting. So ultimately you want to convert carbon to protein. That's the whole goal of what we're trying to do here. And so that efficiency. And so you don't want to do anything else other than producing biomass and protein. And so that's something, again, that's all based on the cultivation parameters and strain dependence to be able to dictate, you don't want it to produce any other sort of byproducts at all in order to have the highest efficiency.
These streams have enough nitrogen, or you need to supplement nitrogen?
Yeah, the question was nitrogen. So with brewery wastewater, you usually have to supplement a little bit of nitrogen, but yeah, you can use a variety of different nitrogen sources. But yeah, so especially with breweries, I mean, they're growing yeast with this product, with their byproducts, and so the nutrient profile is actually ideal for growing fungi. So you don't need that much supplementation, and it's actually a pretty balanced nutrients. Cool. All right, well, I hope it was interesting and fun. Thank you.
So you got a presentation that they don't